All right, we are going to now start the last lesson of this first semester. Okay, it's most people don't find this one too difficult, so that's good news. So here we go. If two sides of a triangle are not congruent, okay, then the larger angle lies opposite the longer side. Okay, so if I'm looking at this triangle down here, so we got three sides, none of them are congruent. It's a scalene triangle. We want to list the angles in order from least to greatest. Okay, and I've left those blank because that is where most mistakes are made. Is you don't read the directions carefully. Sometimes I'll say least to greatest. Other times I'll say largest to smallest. Sometimes, yeah, it depends on the problem, really. So you just have to make sure you pay attention to that. So here we're looking at the least to the greatest. When I'm looking at that, I look at the smallest side. Okay, so the smallest side is KL. The angle across from that, or opposite that, is the angle that's not a part of that side. So angle M is the smallest angle. So angle M would be the least. And then it just goes in order from there. So this one's next. The angle across from that is angle L. And then the largest angle would be angle K. Okay. Now one thing I do want you to notice is you can only order these angles. You cannot find the actual measure of each angle. Okay, so it does relate sides to angles a little bit, but you can't actually find the measure of an angle yet. All right, so yeah, so I can't say that this is like 100. I don't know what the measure is. I just know that it's bigger than the other two. Okay, another example. In triangle PHT, side PH equals 16, side TP equals 20, and side TH equals 13. List the angles in order from largest to smallest. And that's one thing I like to do is I can underline what I'm doing. So I want the largest angle first. Well, I see that this is the largest side, so the largest angle would be the one that's not included in TP. So yeah, T and P, the one that's not included is H. So angle H is my largest. Next biggest would be this one, and that would be angle T. And the next one would be angle P. Now, how did I do that without seeing anything? Okay, I know, and you may have heard me say it, TP is side TP. So if I'm going to draw a triangle here, TP is 20. I know that the angle opposite that is the angle, the vertex, the letter that is not on that side. So the only letter that's not on that side is H. So I know that H has to be the biggest. PH was 16. So I know that the angle that's associated with that one is the one that is not P, it's not H, it's got to be T. Which is why the last one I know is P. Okay? Theorem 2, which is kind of the opposite of Theorem 1. If two angles of a triangle are not congruent, then the larger side lies opposite the larger angle. So it's basically just backwards. Okay, so list the sides in order from smallest to largest. All right, so I have two angles. I can find out the third. You will want to do that first. So it's 45 plus 75 plus angle M equals 180. So 45 and 75 is 120. So angle M equals 60. So I want to go from smallest to largest. So this is my smallest. What side is opposite that angle? Well, it's side MN. You could also say MM means the same thing, but MN is the smallest side. Okay? Notice how you have two letters to name a side, one letter to name an angle, or three. You use three also. Okay, next smallest was 60 degrees. the side across from 60 degrees is ON, or NO, doesn't matter how you say it. And then 75 is the largest angle, so MO or OM would be the longest side. Okay? Hopefully this is pretty easy so far. A little bit more challenging here. List the sides of DVQ in order from longest to shortest. So I'm going to go longest to shortest. Given that angle D is that, angle V is that, and angle Q is that. Well, I just gave you some algebra to do here. These have to add up to 180. But we have to figure out what those angles are before I can order them. So I know these add up to 180. So 51 plus 4x plus 3 plus 5x minus 18 equals 180. Solve for x. I'm going to get 9x. 51 plus 3 is 54. 54 minus 18 is 36. 9x equals 144. X equals 16, I believe. Just make sure real quick. Yep, x equals 16. With that in mind, I can plug x in, and I get, make sure that this is right, 4 times 16, 64, plus 3, this is 67. 5 times 16 is 80, minus 18 would be 62. Just to make sure I did it right, I'm going to add these three numbers up to make sure they add up to 180. 51 plus 67 plus 62, and it does. Now it should be easy to order these from longest to shortest. And I want you to finish that up right now. Okay, so I'm going to check that one in class. Which side is shortest in the following diagram? Now this one's a little tricky. Okay, so we need to find other angles. Okay, so let's fill these in. This is 40, this is 90, so this has to be 50. This is 30. These are equal, so that means these angles have to be equal. So 180 minus 30 is 150, divided by 2 is 75. So now I'm going to look at just triangle PQR. And I'm going to look at the shortest side in that triangle. Okay, so in triangle PQR, the shortest side is QR. Right? 30 is the smallest angle. QR would have to be the smallest or the shortest side. Okay, now I'm going to look at triangle RQS. What's the shortest side there? Well, the 40 is right here, so RS has to be the shortest. So now, is there any way I can compare QR and RS? Because if this is the shortest in that triangle, and this is the shortest in that triangle, one of those two has to be the shortest side. Well, I can also see that QR is in both triangles, and QR has to be longer than RS, because 50 is bigger than 40. So that makes RS our shortest side. Notice I can't figure out how long it is, I just know it's the shortest. Okay. Now for the last theorem. This is one that you're going to use quite a bit. And what it says is the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay? So what this theorem says is that A plus B, the sum of any two sides, is larger than the third side. So A plus B is larger than the third side. A plus C, any two sides are, when you add them up, they're longer than the third side. And B plus C is larger than A. I'm going to explain it another way here. Let's imagine I'm trying to get from point A to point B. Okay, I want to get from point A to point B. We're going to label that X. The distance from point A to point B, the shortest distance between 2 points, is a straight line. Okay, but let's say there's some construction. Let's say there's a road. There's some construction going on, and I can't get through. This is closed. So I have to take a detour, and I have to go to point C before I go to point B. So I have to go here and then here. Okay? If the detour were shorter than the original, I would just take the detour all the time, and this road would be not needed, which doesn't make any sense. Okay, so what this is saying is the shortest distance is a straight line, which means an alternate route has to be longer than the short route. So the other two sides of a triangle have to be longer than the third side. That's what this is saying, another way of saying that. Okay? So, how we're going to use this theorem in these next couple problems. Can a triangle have the given side lengths? Okay? 4, 6, and 9. Can a triangle have those side lengths? Can it happen? Okay? So what you need to do here is you need to look at every combination. 4 plus 6, 6 plus 9, and 4 plus 9. Okay? You have to combine every combination. And you have to check to see, is it bigger than the third side? So 4 plus 6 has to be bigger than 9. 6 plus 9 has to be bigger than 4. And 4 plus 9 has to be bigger than 6. Is it? Let's check. 4 plus 6 is 10. 10 is bigger than 9. We're good. 6 plus 9 is 15. It's bigger than 4. We're good. 4 plus 9 is 13. It's bigger than 6. We're good. So if they're all good, the answer is yes. A triangle can have the given side lengths. 12, 3, and 7. Now, let me give you a little shortcut here. You don't really have to do all three. If you take the two smallest, so in this case 3 and 7, and check them versus the largest, you've checked all of them. Okay, so if I look at 3 plus 7, is it greater than 12? 3 plus 7 is 10. Is that greater than 12? No. So this is not going to be able to make a triangle. Okay, so really you don't have to do all three. You can just do the two smallest. So over here, if I were to look at this a little bit quicker, I would look at 4 and 6, see that they make 10. 10 is bigger than 9, so yes, it can make a triangle. That's all I would have needed to have done. Over here, the two smallest are 5 and 5. So 5 plus 5, is it bigger than the third side? Well, 10 and 10, they're equal, but they can't be equal, right? The shortest distance is a straight line. If there's an equal distance, that idea is false. So I can't have them equal. So no, I cannot have a triangle with side lengths 5, 5, and 10. Okay? Last example. The lengths of two sides of a triangle are given. Find all the possible lengths of the third side. These will have infinitely many solutions. The only way to show this is infinitely many solutions. So to show all of them, we need inequalities. Because inequalities are a way to show multiple infinite solutions. Okay? Now, I'm going to go the long route with this first one, and I'm going to show you a shortcut for part B. So, assume 9 is the longest side. Okay? So these are two sides, and I'm going to say assume that 9 is the longest side. Okay? If you do that, if 9 is the longest side, that means 7 plus the unknown side, we'll call it x, has to be bigger than 9. That's what the theorem says. Two smaller sides have to be bigger than the largest side. Well, if I solve that for x, I get x is greater than 2. So x has to be bigger than 2. Well, what happens if 9 is not the largest? Or not the longest. Okay, 7 definitely is not the longest because it's smaller than 9. But assume 9 is not the biggest. Let's assume x is bigger than 9. Well, then I would do 7 plus 9 has to be bigger than the third side, which we don't know. Well, 7 plus 9 is 16. So if I write this with my variable on the other side to be consistent, the variable's on the left here. I'm going to put the variable on the left here. It's eating the 16, so it's got to continue to eat the 16. X has to be less than 16. So it's got to be bigger than 2, but less than 16. So you might be thinking, that's not an infinite number of solutions, because that would be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you'd be right if you were only talking whole numbers. But all the decimals and fractions in there also could be side lengths. So the way we write our answer is as a compound inequality with x in the middle. So x has to be between 2 and 16. Now, I told you I was going to show you a shortcut, and I'm going to show you where the shortcut comes from. What's 7 plus 9? It's 16. What's 9 minus 7? It's 2. Now, where do those... So really all you have to do is add the two numbers and subtract the two numbers to get these. That's the shortcut. But understanding where that shortcut comes from is important. So the subtraction is because, look at this equation here, inequality. What you do is you subtract 7, and that's where the subtraction comes in. When 9 is largest, when 9 was not the longest, you added the 7 and the 9. So that's where those two things come from. So quickly on this one, your third side would have to be between, not equal to. 23 minus 14 is 9. 14 plus 23 is 37. So the third side would have to be between those two. And that is the end of this video and the end of this semester's videos. Congratulations.